Welcome to this explainer. We're diving right into the sensationalist headlines around Q-Day to separate the actual math from the doomsday hype. If you follow the crypto space, you've definitely seen the articles warning that quantum computers are about to instantly drain the blockchain. But we have to ask, is quantum computing an immediate crisis for cryptocurrency, or is it more of a manageable engineering challenge? Today, we're going to look strictly at the data, the code, and the proposed upgrades to find out exactly what is at risk, and more importantly, what's actually being done about it.
Okay, let's kick things off with this massive number. 5.4 million. That is the amount of Bitcoin currently sitting in quantum vulnerable addresses. At recent valuations, that represents well over $350 billion in wealth. And guys, we aren't talking about some theoretical vulnerability here. We are talking about a mathematical certainty if a powerful enough quantum computer is built. But why are these specific coins at risk, while others might be perfectly safe?
Section 1, Demystifying the Quantum Threat. Let's look at what quantum can actually break.
To really understand why a trillion-dollar industry is at risk, we have to cut through all that conflated public hype. The absolutely crucial point is that we're talking about a highly specific threat known as Q-Day. This is the hypothetical moment when a cryptographically relevant quantum computer, or a CRQC, finally goes online. And make no mistake, intelligence agencies aren't just sitting around waiting for Q-Day to arrive to start worrying. They're already operating on a harvest now, decrypt later strategy. They are literally downloading encrypted data and public blockchain ledgers right now with a full intent of breaking the encryption the absolute second they have the hardware to do so.
So let's separate fact from fiction. A lot of people think a quantum computer will just magically take over Bitcoin mining. It won't. Quantum computers do not break Bitcoin's mining hash, known as SHA-256. While a quantum algorithm called Grover's algorithm could technically speed up hashing, it doesn't break the system. The network would simply adjust the difficulty to compensate. The real threat here is Shor's algorithm. This algorithm absolutely obliterates the elliptic curve signatures, specifically ECDSA, that are used to authorize the actual spending of your cryptocurrency.
Section 2, the exposed public key problem. So whose coins are actually at risk?
If Shor's algorithm can derive a private key from a public key, we have to ask a very pragmatic question. How do public keys get exposed in the first place? Well, it happens in a few ways. The vulnerability depends entirely on whether your public key has been broadcast to the public ledger. In the early days of Bitcoin, the default address format known as pay to public key, or P2PK, made public keys visible by default. But even with modern wallets, there's a major catch. The very moment you spend Bitcoin from an address, your public key is broadcasted and recorded permanently. This means the only truly safe coins right now are in addresses that have only ever received funds and have never, ever sent them.
This perfectly illustrates the sheer scale of the issue. When you tally up all the legacy addresses and all the reused addresses where people have sent funds, about a quarter of Bitcoin's total circulating supply is mathematically exposed. That is roughly 25% of the network sitting completely vulnerable to anyone who eventually builds a stable, fault-tolerant quantum computer. And the danger seriously compounds when we look at other networks like Ethereum. Ethereum's exposure is actually much broader. Somewhere between 50% to 65% of all ETH sits in vulnerable accounts. Why? Because unlike Bitcoin's model, where the best practice is to generate a new address for every single transaction, Ethereum operates much more like a traditional bank account. Users have one account, they reuse it constantly, and the moment they send their very first transaction, their public key is revealed to the network permanently.
Section 3, the Satoshi wallet controversy. This is where the multi-billion-dollar drama really kicks in.
This massive network exposure brings us to an ongoing intense civil war over abandoned coins, specifically the roughly 1.1 million early mined Bitcoin widely believed to belong to Satoshi Nakamoto. Because these were mined in the network's earliest days, they are sitting in highly vulnerable, permanently exposed P2PK addresses. If a quantum computer comes online, these dormant coins are the ultimate honeypot. And man, this has sparked a fierce debate about what the network should actually do about them. On one side of the debate, we have pragmatists like Binance founder CZ. They argue that the network simply must implement a hard upgrade to freeze these legacy coins. Their logic is pretty straightforward. If a quantum thief accesses Satoshi's wallet, they could dump 1 million Bitcoin onto the open market, instantly crashing the price and draining billions in value. To them, freezing the vulnerable coins is just a necessary security measure to protect the broader ecosystem. But on the other side of the aisle, decentralization purists are pushing back forcefully. As investor Michael Turpin points out, freezing property violates the absolute core ethos of Bitcoin. The network was designed to be permissionless and censorship-resistant. The main counterargument goes like this. If the community agrees to alter property rights and freeze Satoshi's wallet today, where does the censorship actually stop? Could they vote to freeze a political dissident's wallet tomorrow? Now, as an explainer, we aren't here to pick a side, but it's absolutely vital to understand that this isn't just a technical glitch, it is a profound philosophical divide.
Section 4, Bitcoin versus Ethereum mitigation.
Setting aside all the philosophical drama over Satoshi's coins, how are these multi-billion-dollar networks actually engineering a way out of this trap? Well, this comparison highlights a really stark contrast in governance and mitigation strategies between the two largest networks. Bitcoin relies on a slow, conservative, and completely voluntary migration path. Developers have proposed BIP360, which would let users voluntarily move their funds to new quantum-resistant addresses. Ethereum, on the other hand, is being much more proactive. They're utilizing hard forks and a concept called account abstraction, specifically EIP 7702, to allow users to dynamically upgrade their individual account signature schemes without even needing to move to an entirely new wallet.
So, what does this mean for the everyday user right now? The incredibly good news is that you absolutely have agency here. You do not have to wait for a network-wide upgrade to protect yourself. First, you can check if your public keys are exposed. Second, and this is absolutely critical, stop reusing addresses. If you generate a fresh receiving address for every single transaction, your public key remains safely hidden behind a quantum-resistant hash. And finally, when quantum-resistant standards like the newly proposed BC1Z addresses become widely integrated, you can just seamlessly migrate your funds over there.
Section 5, the realistic quantum timeline. Let's look at when Q-Day might actually happen.
So we know the threat and we know the mitigation strategies, but how much time do we actually have to fix this? Following the data, we really aren't facing an overnight doomsday. The timeline is actually quite visible and predictable. In 2024, the National Institute of Standards and Technology officially finalized its post-quantum cryptography defense standards. And if we look at the hardware roadmaps from tech giants like IBM and Google, they're heavily targeting the capability for cryptographically relevant machines between 2030 and 2033. Validating this timeline even further, the NSA has mandated that all national security systems must transition to post-quantum algorithms by 2035. So, the real threat window realistically opens in the early 2030s.
Section 6. The final verdict. Is crypto ultimately doomed?
All right, after reviewing the hardware data, the on-chain exposed ledgers, and those incredibly fierce governance debates, what is our ultimate takeaway here? The critical verdict is that the crypto industry already has the technical tools it needs to survive this. Technologies like lattice-based cryptography are currently being developed to replace those vulnerable elliptic curves. This means the real bottleneck isn't the technology itself. The true challenge is human coordination. It's getting decentralized global networks of miners, developers, and users to agree on how and when to implement these upgrades without totally tearing the community apart in the process.
And I'll leave you with this final thought to chew on. As that 2030 to 2035 deadline steadily approaches, will these passionately decentralized communities be able to overcome their governance civil wars in time to actually protect your assets? Or will their commitment to absolute immutability be the very thing that leaves billions of dollars completely unlocked for the world's first quantum thief? It's a wildly fascinating space to watch. Thanks for joining me on this explainer, and keep learning.